Okay, so today we're going to be looking at proof by contradiction. The learning intention is basically to gain the understanding of the knowledge in constructing proofs by contradiction. So we'll be successful again state and phrase contradiction of assumptions and execute the steps to prove that assumption is false. So from our Maths in Focus textbook, proof by contradiction works by taking an assumption that the direct opposite of a statement, in other words, its negation, is true, and then by showing by logical argument that the assumption is false. I'm going to do a couple of examples. The more we do, the better we become at it. One of the common proof by contradiction is that square root 2 is an irrational number. So I would, where possible, kind of memorize this. Or memorize the steps, okay? So the first part is that we want to assume, so the first part of a contradiction is assume that the direct opposite of this. So we're going to assume that the square root of 2 is a rational number. Okay, so by contradiction, the direct opposite, yeah. So we're going to assume that root 2 is a rational number. So that means that there exists P and Q, some numbers P and Q, which belongs to the set of integers. Q can't be 0, and I'll explain why. So in other words, I can write it as, so that there exists. So I can write this as there exists P and Q belonging to the set of integers. Yep. And Q can't be 0. Such that we get the square root of 2 is equal to P over Q. Yeah. That's why Q can't be 0, because if we had a 0, it would be divided by 0, which is undefined. Okay. So assume that it's a rational number, so taking its direct opposite. So there has to be a number P and Q, right? So the square root of 2 has to equal a rational number, yeah, where Q can't be 0, but it belongs to some integers, the set of integers, some whole numbers. So the first step I will do is to get rid of that square root 2, I'm going to square both sides. That will give us 2, that just gives us 2. That will give us P squared over Q squared. And rearranging it, we get 2Q squared equals P squared. Okay. So this, what that means is, so if P squared is a multiple of 2, then P is also a multiple of 2. One thing I did forgot to mention, sorry, the square root of 2 equals P and Q, where P and Q share no common factors. Yep, because we want a fraction. That's irrational numbers can be represented as a fraction. Okay, so where P and Q share no common factors. Okay, so P squared is a multiple of 2, then P is also a multiple of 2. Okay. Therefore, P would be 2k, where k is an integer. Yep. If I square this, so P squared would be 2k squared, which would be 4k squared. Yep. But we also know that P squared is also equal to 2q squared. So 4k squared has to equal 2q squared. Yeah. If I divide by 2, I get 2k squared. Okay. So that means that q squared is also a multiple of 2. And if that's the situation, then q is a multiple of 2. Alright. But as q and p are both multiples of 2, they share a common factor. And that's what we don't want. So, by contradiction, of the assumption that P and Q have no common factors, the original statement is wrong. So therefore, the original assumption is wrong, and therefore square root 2 is an irrational number, QED. Okay. QED stands for Quod Erat Demonstratum, which means as required to prove, as demonstrated to the proof. Okay. So that's one that you would probably want to remember, or definitely the steps. Okay, because you might be asked to reproduce that. Okay, the next one. We want to prove the contradiction that log 2(5) is irrational. So the statement is that log 2(5) is irrational. So we're going to do a proof by contradiction. So the first thing we're going to do is we're going to assume that log to the 5 is rational. Okay, so that is there exists P and Q in a set of integers Q can't equal 0 such that P and Q have no common factors. So as you can see, this part is the same as the log, the square root of 2 being irrational. Okay, so we could write this part as, so there exists P and Q in the set of integers where such that P and Q share no common factors, and Q can't equal 0, so that we have log 2 of 5 being a rational number. Okay, and we can write this as index form. So we can write 2 to the power of PQ is equal to 5. Okay. Okay. Now, since 2 is even, yeah. Sorry, before I do this, I'm going to actually multiply both sides by Q. I'm going to get 2P equals 5Q. Okay. So since 2 is even, then 2 to the power of P must also be even. Yeah. As 5 is odd, then 5 to the power of Q must also be odd. Okay, we can't have a number that's even also be a number that's odd. Okay, so therefore 2 to the power of P doesn't equal 5 to the power of Q. Okay, so by contradiction, since 2P doesn't equal 5Q as an even number, cannot equal an odd number, okay, the assumption is wrong. So therefore, log 2 to the power of 5 is an irrational number. Okay. All right. That's a good one to also remember as well. Okay. Let's look at this one. I've actually done the example, so we can go through it. So we're going to prove by contradiction that 5n plus 3 is odd, and then n has to be even. Okay, so this is odd, then that has to be even. Okay, so we're going to assume for contradiction. So assume for contradiction that 5n plus 3 is odd. So we're going to keep this part the same, but we're going to negate this part. Then n is, rather than being even, it's going to be odd. Okay, so since n is odd, n has to be equal to 2k plus 1. All right, so some things that you might want to understand is that n means a number, 2n means an even number because it's divisible by 2, and 2n plus 1 is an odd number. Okay, so the odd number. Okay, so if it's an odd number, we got 2x plus 1, n has to be 2x plus 1 for some integer of k. Yeah, so if it was 3, 2 times 3 is 6, plus 1 is 7. Yeah, if k was 4, 2 times 4 is 8, plus 1 is 9. So it becomes odd. Okay, so if we have this 5n plus 3, what I'm going to do is I'm going to replace that n with the oddness. Yeah, I'm going to expand. So we get 10k plus 5 plus 3, that's 10k plus 8. Take out a factor of 2. As soon as we can be able to take out a factor of 2, it shows that this is an even solution. Yeah, because this is 2 times some number. So we need to say, since 5k plus 4 is an integer, 2 times that integer is an even number. It can't be even and odd. So hence 5n plus 3 is even, and it cannot be both odd and even. Hence the assumption for n must be wrong. So n has to be even. So by contradiction, 5n plus 3 is odd and n is even. Okay. So one other example. All right. So we're going to prove by contradiction that a triangle with sides 3, 4, and 5 is a right angle triangle. Okay. So the statement is we get 3, 4, and 5 is a right angle triangle. So we're going to assume that a triangle with sides 3, 4, and 5 is a non-right angled triangle. So using Pythagoras' theorem, that the hypotenuse squared is the sum of the square of the other two sides, where the hypotenuse is the largest. Yeah, so we've got c squared equals a squared plus b squared. So if we let c be 5, a be 4, and b be 3, so the left-hand side is c squared which is 5 squared, which is 25. And the right-hand side is a squared plus b squared, which is 4 squared plus 3 squared, which is 16 plus 9, which is also 25. Yeah. So so the left-hand side currently is equal to the right-hand side where it shouldn't be. Yeah. So we're assuming that c squared doesn't equal a squared plus b squared. So by contradiction, so by contradiction, the square of the hypotenuse is equal to the sum of the square of the shorter sides. So the assumption is wrong. Therefore, a triangle with sides 3, 4, 5 makes a right angled triangle. Okay, and that's it. So if we're doing a proof by assumption that is by contradiction, a proof by contradiction, we assume that the statement is the direct opposite. Okay, thank you very much.